Hello and welcome to another video lesson. Today we're talking about product to sum and sum to product identities, and we're going to be able to use them to evaluate trigonometric expressions and solve trigonometric equations. So that's our goal for today. Okay, let's take a look at product to sum identities. All right, sometimes we're going to be given, especially in a calculus sense, we might be given cosine of 5x times sine of 3x, something along these lines. And it's going to be a lot easier if we can rework this to be the sum or the difference of some angles. All right, so this is where this kind of comes in handy. Okay, and we're going to prove that the cosine of alpha times the cosine of beta is equal to 1/2 cosine alpha minus beta plus cosine alpha plus beta. Okay, and we're going to rely on our knowledge of sum and difference identities, as we know that cosine of alpha minus beta is equal to cosine of alpha times cosine of beta plus sine alpha times sine beta. So we're just going to do some substitution over here. Okay, and remember, when we're working with an equation like this and trying to prove, we want to work with the most complex side. So we're going to work with this left-hand side, or this right-hand side here. Okay. So I have 1/2. Okay, cosine alpha minus beta, that's going to be cosine alpha times cosine beta, okay, plus sine alpha sine beta. Okay, and then I've got cosine alpha plus beta. Well, that's going to be cosine alpha cosine beta minus sine alpha sine beta. Okay, so I've got plus sine alpha sine beta and minus sine alpha sine beta, so those will cancel out, and I'm left with 1/2, and then I've got 2 cosine alpha cosine beta. Okay, I've got one here and one here, so we can add those. So I've got 2. Okay, so my 1/2 and my 2 will cancel out, and I'm left with just cosine alpha cosine beta, which is what we have here on the left-hand side of our equation. So that checks out as an identity. Okay, so we're not going to prove all of them, but I will put them up. Okay, so we can see. I'll go ahead and erase this so we can write these down. Make sure we have these in our notes. All right. Okay, and then for every product to sum identity, we also have a sum to product identity. Okay, and we're not going to go ahead and prove these, but we're really just manipulating those equations to get these identities here. So make sure you write these down as well. Okay, our first example, we're looking to rewrite our term here as a sum or a difference. Okay, so for this one, we're going to rely on one of our product to sum identities that says sine alpha cosine beta is equal to 1/2 alpha plus beta, sine alpha plus beta plus sine alpha minus beta. Okay, so our alpha in this instance is going to be this 4 theta. This is our alpha, and this is our beta, right? Okay, so we've got 1/2 sine, okay, my alpha, which is 4 theta, okay, plus beta, which is just 1 theta, okay, plus, let's see, sine of alpha minus beta, so it'd be 4 theta minus beta, okay? Getting that straight off of our identity here. Okay, so this will be 1/2 sine of 5 theta plus sine of 3 theta, right? Okay, and then just to finish it off here, we're going to distribute our 1/2, so it's going to be 1/2 sine of 5 theta plus 1/2 sine of 3 theta. Okay, that would be rewriting our term as a sum or a difference, in this case a sum. Okay, let's move on to example number 2. Find the exact value of our expression here. Okay, we're going to need to use our product to sum identity again, okay, because I don't really know what cosine of 37.5 is or what cosine of 187.5 is. Okay, so we're going to use our cosine alpha cosine beta here and rewrite this as, let's say this is 3 times 1/2 okay, cosine of 37.5 degrees minus 187.5. 187.5 degrees. Okay. Plus cosine of 37.5 degrees plus 187.5 degrees. Okay, so this will be 3 times 1/2. And then this will be cosine of negative 150, negative 150 degrees, plus cosine of 225 degrees. Okay, 225 degrees. Okay, so I know cosine of negative 150, if I look at my unit circle, is going to be negative root 3 over 2. Okay, plus cosine of 225 degrees is going to be negative root 2 over 2. Okay, that's what I have here. Now in my parentheses, and we're multiplying that by 3 over 2. Okay, so we can go ahead and multiply through. Okay, I'll distribute my 3 on top, and then this will be negative root 3 plus or minus root 2 in my numerator, all over 2, okay, times 3 over 2. Okay, I'm going to go ahead and distribute my 3 here. So this will be negative 3 root 3 minus 3 root 2, all over 2 times 2 is just 4. Okay, so this would be my exact value of this expression. Okay, last example here. Okay, we're asked to solve a trigonometric equation. All right, and we're going to need our sum to product identity for this one. Okay, sum to product identity for sine plus sine. Okay, so we're going to rewrite this side of my equation as 2 sine. Okay, my alpha plus beta, so my alpha is x and my beta is this 5x, right? So I've got x plus 5x all over 2 times cosine alpha minus beta, so it'll be x minus 5x all over 2, okay? All over 2. All right, so I've got 2 sine of 6x over 2 times cosine of negative 4x over 2. That's going to be equal to 2 sine of 3x cosine of negative 2x. And that's equal to 0, right? Set that equal to the right-hand side of our equation there. Okay, I can divide both sides by 2, so my 2 goes away. So 2 goes away. And then I'm left with sine times cosine equals 0. Okay, well, we can use our zero product property at this point and say sine of 3x equals 0 and cosine of negative 2x equals 0. Okay, use our zero product property there for that. Okay, if I take the inverse sine of both sides here, I get 3x is equal to inverse sine of 0. Okay, inverse sine of 0 is going to be 0. Okay, but instead of 0, I'm actually going to use 2 pi. Okay, I'm going to use 2 pi for this one, so I'll have 3x is equal to 2 pi. Okay, those are coterminals, so that's all right. So then I go ahead and divide both sides by 3, and I get x is equal to 2 pi over 3. All right. And here, if I take the inverse cosine of both sides, I get, well, first before I do that, let's think about cosine as a function. Okay, cosine has this even property, right? Cosine is even, meaning cosine of negative x, that's equal to cosine of x. Okay, since we have that even property, or that negative can kind of go away. Okay, so this is going to be, I'm going to rewrite this as cosine of 2x. Okay, positive 2x is equal to 0. Okay, so now I take the inverse cosine of both sides. I'm left with 2x is equal to inverse cosine of 0. Okay, inverse cosine of 0 is going to be pi over 2 as well as 3 pi over 2, right? We'll have 2x is equal to pi over 2 and 3 pi over 2. Okay, when I divide both sides by 2, I get x is equal to pi over 4 and 3 pi over 4. Okay. Now let's think about cosine here. Okay, what's the period of, say, cosine of 2x? Well, my period would be 2 pi over this coefficient of 2 here, right? So my period is actually pi. Okay, so when I'm doing my final solution here, okay, I'm going to have this pi over 4, right? And I have 3 pi over 4. Okay, but anytime I add n pi to that, right, to both of these, okay, we end at a coterminal angle, right? Okay, so, well, not necessarily a coterminal, but because of our period, okay, it's going to fit the solution here, okay? So that's for cosine. How about for sine? So here I've got sine of 3x. Let's figure out where to do this. Sine of 3x. Okay, so my period here is going to be, again, 2 pi divided by this coefficient of 3. Okay, so my period is 2 pi over 3. Okay, so here we've got this 2 pi over 3. Oh, and I also forgot another solution here is going to be, here I've got 2 pi, but I also have pi here, right? I also have pi. So when I divide by 3, I have 2 pi over 3 and pi over 3. Okay, and since I've got, this is the first part of my solution for cosine. Okay, since I've got this 2 pi over 3 here, okay, I can just say a 2n pi over 3, okay, since my period is 2 pi over 3 as well, okay, 2n pi over 3 is going to fit my solutions here, as well as pi over 3 plus my 2n pi over 3, okay? Give it a little bit more space here, 2n pi over 3. Okay, again, because of our period, that's why we're adding this 2 pi over 3. And for both of these, I need to specify that the n values here are integers, okay? N values are integers, so I need to add that with my solution, okay? So these 4 x values, or 4 expressions, okay, for x are going to be my solutions for this trigonometric equation, okay? So that is all for this lesson. Good luck with your practice.